This is the summary video in the Thinking Algorithmically series. And so we have two videos where we go through the development of some algorithms. And in this video, we're going to talk about, we're going to try to summarize what we've done and describe the basic process that we followed. Recall that we're using this broader definition of an algorithm of the two here, that we're looking for this step-by-step procedure for solving a problem or accomplishing some end, especially by a computer. And so we're trying to develop a formalized procedure for solving a particular problem. And in the previous two examples, the first one we looked at, or the previous two videos I should say, we looked at the development of pseudocode or an algorithm for determining the sample mean, computing the sample mean from a set of observations, followed by a pseudocode for, or again an algorithm for determining the sample variance. And then in the second video, we looked at a more comprehensive problem called the assignment problem, and we looked at several different algorithms for solving that problem. So in developing the algorithms, there are four critical concepts, or what we're going to refer to as the four pillars. This is an extension of the idea presented in Lutz, the course textbook on Python, on page 94, where he described three of the pillars and I added one to it. So the pillars are the basic concepts that underlie our algorithm development. First is something called assignment. Second, sequence. Third is selection. And fourth is repetition. And we will look at these basic concepts and describe them in a little bit more detail, and then go back and look at the algorithms we've developed and identify these components, hopefully putting forward the notion that basically all of our algorithm development can be broken down into these four basic concepts. So firstly, with assignment, we are basically assigning a value to a name. So we're assigning a value to a name. And we use these terms, both of these terms, kind of loosely, as we'll see some examples. We have some very straightforward examples. So some of the things that we've seen before in our algorithms are when we initiated our counter, we had count equals 0, and then later on when we were incrementing the counter, we had count equals count plus 1. And in both of these examples, we are assigning a value to a name. And so in the first example, we are assigning the value 0 to count. So then when we come back and refer to count, we can then determine or use that value. In the second example, we're actually getting the value, we're reading the value. And if we think about the initial time through the loop, for example, this will have a value of 0. And so we're retrieving the value and we're using that in a mathematical expression. And then we are then going back and storing it to the name. We also have more comprehensive or not so straightforward assignments of a single value to a name. So we had things like sequence is equal to 1, 2, 3, 4, for example. And here the notion is that we are assigning the list or the sequence of numbers to the name sequence. And so that's the same type of concept of an assignment. And then the final example that we have that we did in several of our assignment problem algorithms is we did something like assign task J to person I. And in this assignment, we don't have quite such a straightforward notion of assigning a value to a name, but instead we're assigning an assignment in this case. We're setting a value saying that the person I is going to be assigned J. And so that corresponds to the same type of assignment, but it's not a specific value to a specific name. Nevertheless, we use it in basically the same way. So going back to our previous examples, if we go back to the sample mean and variance algorithms that we did, clearly these are both examples of assignment. These are both examples of assignment. And this is our final example of assignment in our sample mean computation. In our sample variance, of course, we also have the assignment here, where we're actually executing a subroutine, or we're calling another piece of pseudocode in this case. When we get to actual code, we'll call it a subroutine, and assigning the return value. So again, a slightly different type of assignment, but the same basic idea that we're assigning values. In this case, we're computing or we're assigning values to the count and to the sample mean through that function call. In the assignment problem, again, we've already talked about a couple of these. You can see basically in all of our algorithms, our LAP algorithms, we assign the cost, we assign the task that we talked about earlier, we increment the cost value, the cost counter, and so on. So you can see that assignment is one of the most important concepts that we do in developing algorithms, so that we can store a value that we're going to then later use for some purpose. So the second concept or pillar that we're interested in is that of, let's slide down here, get rid of the green here, and talk about sequence. The idea of sequence is that the order of execution is important in some cases. So in other words, we have this notion of do this before, let's see if I can spell before correctly, before that. Right, and this notion that doing things in order is important. So again, if we go back to our assignment problem, for example, let me see one of our pseudocodes here. Right here is an example. So we have our assignment where we assign the, let me grab a different color here, where we assign the task J to person I, and we have to make that assignment before we can actually increment the cost, because this assignment is actually what lets us pick that cost from our cost matrix. And so it's important that we do one thing before we do the other. Similarly, if we, let's see, look at sequence here on STT2, where we were computing the value of two different sequences. We were computing the assignment cost for sequence 1 and sequence 2. Before we can make the decision of which one's better, we have to actually do that computation. We have to make this assignment, in this case, of the cost to that value. And so the notion of sequence says in many cases it's critical to follow a particular sequence. So this concept of sequence is a little bit less well defined if you think about it than assignment, or at least it's hard to point out specific cases. It doesn't relate directly to code, but it goes back to the basic notion of doing things sort of one step at a time, and then having the correct order of execution. Our third pillar here is selection, and so selection basically says if some condition is true, if some condition is true, then do something. And so this is what we saw when we talk about an if condition. So going back to our code, back to our sample mean and variance, for example, we had an example of this if condition here, right here, where we were checking for the boundary condition. If you remember, we can't compute the sample mean if we don't have any numbers, and so we interjected this check to say if count is greater than 0, then we can compute the sample mean. So in the context of selection, this says if some condition is true, and that condition in this case is that we have at least one number, then we can do the sample mean. Then there's the alternative that says, okay, well, if the condition is not true. So we can think about that as two selection conditions, if it's true and if it's not true. And so we typically combine those into this if-else structure, but it's just two examples of the notion of selection. And finally, our fourth pillar is the notion of repetition. And in repetition, we're essentially going to do something multiple times. And in our algorithms, we saw several examples of this. These examples were characterized by while a condition is true, while some condition is true, we executed a series of functions, and we did for each. So for each element in a set, we did some conditions. And we can also have for a fixed count. So we think about a for I equals 1 to 10. where we want to execute something a fixed number of times. So these are all examples of repetition. The first one says we're checking for a specific condition. The second one says we're going to iterate through a finite set. The third one says we're going to iterate for a fixed number of times. But yet again, all of these are examples of repeating something multiple times. And if we go back to our previous code examples, if we look at our pseudocode for the sample mean, you can see that we have this repetition right here where, oops, I don't mean to get that part of the code. Let me see if I can do this better here, get rid of that guy, and say what we're interested in here is just this little block right here. Well, we were saying while there was some condition holding, so this is the condition here is there are numbers left, and so the assumption is we're peeling off numbers one at a time. While this condition is true, we execute this. Note that in subsequent examples, we did a very similar thing. So we're iterating through a finite number. We did here using the while. We said while there are numbers left. While in the assignment problem, we did something very similar. Here's an example where we said for each person. So person, people is a set. We have a set of people in our problem, and we're iterating through each one of the people. And we're executing this code for each person in that set. And so functionally, these two things are equivalent. In this case, we're iterating through a set using the for each notation. And whoops, wrong one. In this, if I can get back to the problem. And in this example, well, I still don't have it. There we go, sample, mean, and variance. And in this example, we are iterating through each one, but we're just using this while structure. And so if we think about this notion of repetition, there's no fixed definition of when you use while, or if you should use while, or the for each, or the for I to one, or whatever. It's just this notion of repetition that generally involves either a condition or a finite number of turns. And so in summary, again, all of our algorithm development, when we think about constructing those, can be divided really into these four basic concepts of assignment, sequence, selection, and repetition.